Hello, this is the Tepid Coder. Today, I want to talk about pointers to class methods. In order to do that, I'm going to make a class that has some methods I can reference. So I'm going to say public. I don't really need any private stuff in here. I'm going to class constructor. We'll make the destructor. We're going to make a function called foo, which takes nothing and returns nothing. I'll make a subtraction function called sub, which returns an integer and takes two integers. That's probably good enough for now. So make my constructor, make my destructor. I'm gonna make my foo method definition. All this is gonna do is just print some stuff to the console. Testing, right? Okay. Standard inline. We're gonna do, let's see, sub here is gonna be a return type, comes from class called sub. Takes int a, let's say int b. I'm going to say return a minus b. Okay, let's make an entry point. Okay. Return 0, so the OS is happy. I'm going to instantiate a class object called C. And there's a couple ways to do this. I'm going to show the old kind of convoluted way first, and then I'll show the modern easier way. So the old convoluted way would be to kind of look at the function as we did with like C function pointers. Look at the return type, and look at the arguments it takes. So this one would be int. You got your parentheses and an asterisk, right? And you could name it in here, right? And then you'd say the arguments it takes, or parameters it takes. And that's your function signature if it's a C function. But since this comes from a class, you say class : this, right? And you can still name it. I'll say it's fn sub, right? That would work for that one. Let's use an easier one though. Let's do void. I'm going to do class : function foo, right? It takes void. And you say it equals a reference to class : and then the actual method in the class is foo. And here it would be class : sub. Now the way you call this is a bit wonky. What you need is actually a class pointer to work on, but this is a just local, class variable. So in order to make it act like a pointer, I'm going to say class pointer, LPC class, LPC, right? Long pointer to class equals a reference to C, this variable here. Okay, and once I have that, I'm going to wrap it in parentheses in order to get the function address. I'm going to say LPC, arrow, asterisk, and then the name of the method pointer, which is fn foo. Okay, then I pass the arguments here. There are no arguments. It turns void, not zoid, and it accepts no arguments. It's also void, right? So let's try that real quick, just show that works. So I'm going to do g++ test.cp, out test, run it, works just fine. Okay, I'm going to show an easier way to do this now, though. This is with standard function. What you can do is you can say the return type. I'm going to do this for the sub function. I'm going to say int. Okay, that's what it returns. And then you say the first type is actually the class object reference, which is kind of interesting, which makes sense. I mean, when you call a class method, the first argument is kind of hidden from you. It's implicitly added by the compiler, is reference to the class itself. So that has to go there first in standard function. Then you say the types of arguments that are actually passed, that all pass myself. So it takes two ints, right? And I'm going to say it's called fn sub. It equals class sub. So now let's say I difference equals, and it's going to be fn sub, and we'll say the class instance is coming from, which is C, right here. Okay. Let's print out the result. C out. Difference. Okay. It's going to be I difference. Into line. And one thing I need to do here is, since I'm using standard function, is I need to include functional. Okay, let's see if that works all right. Okay, so what did I get wrong here? No match to call. We have returns int, takes a class instance reference and two more integers. Okay. Oh, right, I didn't actually pass the arguments. I passed the class it's coming from. Let's do 1 minus 2. Now it should be happy. Okay, test, and it's working just fine. Now I want to show a practical example of this, but in order to do that, I'm going to have to type a lot of code. So what I'm going to do is I'm going to defer to future me for that. So if you want to stick around and see a reason you might want to use these method pointers, then feel free to hang out with future me. But past me signing out. Catch you later. Hello, this is future Tepid Coder here. I coded out the project so I can show exactly how method pointers could be useful. I still have the footage of myself programming the thing, but I think that it went on a bit too long, so just walking through the code will be better. But first here I'm going to show what it does. So we have these different phases. So here's phase 1 is like enter your username, password, right? Type encoder. This password sucks, right? So that happens. I can switch between phases, right? So phase number 2 is going to be the server address. There's no place like 127.0.0.1. There it is, right? And it retains the values if I go between them, right? So I want to go back over here again. I can show the same thing again. Resize the window, you know, all the elements resize with it. That's all cool. So I'll show how that works real quick. So first of all, I create an instance of this window manager class that I made, and then I'm going to return whatever the result is of creating the window. Well, here's that create window class. I have to define a window class exw structure, which the W being wide character. When you compile your project for Unicode, it uses wchar t for most of the types internally, and there's actually a t char that it would decay into a w char like this. It doesn't decay into it, it's defined as that, depending on how you build your project. If it's building for Unicode target, then this becomes this. Otherwise, it's going to be this. Anyway, I basically fill the Windows 32 API stuff. I register the class, I create the window, and when I create the window, there's an extra argument here you can use, which lets you pass some user data. So I'm doing that to pass this class instance, this class being window manager, right, as defined down here. Okay, so if I succeeded in creating the window, that I get to continue, otherwise I'm complaining. So another way to do this, if I didn't want to pass the class instance in this extra argument, is I could just say set window long pointer, and it would set it in some kind of window property that I could pull out later with get window long pointer. Anyway, I did it this way, and yeah, both methods are completely fine. So what's going to happen here is it's going to call the window procedure that I said, and it's going to keep pumping messages into it inside of this loop. It'll keep doing that until it receives what is called the wm quit message. So wm quit equals break. So let's look at this right here. Okay, so what this does is when it's created, it pulls that window manager argument out and stores it in a static variable. So it's going to start out as null pointer, but every time after that it's going to persist and keep its value because it's static, and it's going to have whatever I passed when I created the window. Okay, and if this is valid right here, because this already happened, it's going to defer the event that happened in this callback function to the update method of this window manager class. Okay, now this still does handle some things, like when you hit the close button, check the X button, it's going to destroy the window. When the window is destroyed, it's going to end the message loop. And if there are any resources, it would free those too. So posting this quit message right here, like I said earlier, it's going to end this loop, which means we return. This returns means we return here too, and that's how the OS gets the response code from the executable. Okay, so let's look at the delegation right here. We have this update method. So inside of the update method right here, we get the size of the client rect, which, I mean, the client rect is, let's show you over here. Basically, the top left is black right here, to the bottom left is black down here. That's all the client rect. That's where I can basically draw content and use buttons and stuff. So it grabs that, and then it decides which phase to use. Now, I'm not using a switch statement with a bunch of cases in order to pick the phase, but I could, and I'll actually show that in a second. What I'm doing right here is using an array of method pointers. Now, this is way faster using method pointers because we just jump to an address in memory based on the index, and then we call the function at that address, or the method of that address really, and pass some arguments to it. Now over here we have to say, okay, are we on phase 0? If so, do this. Nope, okay, check, are we on phase 1? If so, do this. If not, okay, we're on phase 2, blah, 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 blah. You get the idea. It has to do it for every single one. If we have like 30 phases, it's doing 30 if statements, or up to, I should say. It could, you know, be on phase 0, so it just does one. But as you go further and further down the phases of the application, it's going to have to check more and more times. So this is a lot more typing. It's annoying to maintain. It's going to be more error prone if more things have to happen in these phases. This is definitely the way to go. It's faster, it's less code, it's easier to maintain, and as I add more setup phases, I don't have to add any more cases. This is just as long as it will ever be. So, first of all, let's show that it still does work with the switch statement and the cases, just so you can see. case someone doesn't believe me. So here it is still. So I'll say the type coder. I'll say this password also. I think I mistyped that. Sucks. We'll see. Yeah, this password also sucks. Wasn't wrong. Okay, server address. We'll do 123.321.123.1. Okay. And it works. Cool. And the Windows is still resized it and everything. So really there's nothing different going on here. It's just that it's a crappier way to do it. So I'm going to put it back on the way that it does method pointers. When I switch between phases, I do it based on a key down event. And the 0 key on the keyboard, not on the numpad, but on the top row, kind of by tilde up to backspace, that 0 has the value 0x30 in the virtual key codes that Microsoft defined. So I'm subtracting that value from whatever was pressed, whatever key I got in the event. And that gives me 0 if they pressed on 0. 1 is one higher, so it gives me a 1, and so on and so forth. And at some point, you know, I'm going into other keys like Shift and Caps Lock and Spacebar. Those also have values. But if I get a value that's greater than the, or equal to, the number of elements I have in the array of methods to call, then I just bail out instead of changing the phase number. But if it's a valid one, then I'll change the phase number. It's kind of redundant to do this here. I should probably just paste that here. Anyway, I also made it so I set focus on the window if I click it. Otherwise, once you type in an edit window, you wouldn't be able to use those keys to switch phases again. So, anyway, let's look at what these methods do. Phase 1, phase 2, and all that. So let's copy this. I want to say window manager phase 1. Okay, here it is. So it handles the event loop. You can imagine I'm getting delegated from the main common loop, right? The common message loop, I think I called it. What is it? Common procedure? Can't remember what I called that. Right here, common window procedure. So this delegates over to my update method. Okay, and the update method delegates to phase 1. Window manager phase 1, right? So this will handle the paint message. It'll basically print out username, password as prompts, and it'll move the edit windows around as the window resizes. And then if you click on that common accept button that exists in all setup phases, it'll take the text you typed in the edit windows, it'll store it in a wide string, it'll format it and say, hey, here's the username and password you typed. I'm using standard V format here with some wide character strings and with make W format args, so wide string format args. So that's kind of a cool thing you can do. This is the first time I've actually used this function, like the wide format version of it. So I had to look that up today, but I wanted to use modern C++ and show it off. Anyway, so setup phase 2 is very similar. All it's doing differently is saying server address instead of username and password up here, right? And it's storing that in a different variable and printing it out verbatim, whatever you typed. Same thing, it'll resize the edit window if the window is resized or moved around. And that's basically the whole project here. I could talk about how like windows get initialized and whatnot, but if people want more explanation of the project or just are more interested in Windows 32 API in general, I can make like a separate like mini series about that or something. But yeah, the main advantage is just that you don't have to maintain something like this. It's way easier and it's a way quicker code execution to do this. So if you like what you saw, please consider subscribing, liking the video, and so forth. If you have any comments and criticisms or suggestions, I like reading comments and I'd like to see what you have to offer. So please do post. I'll catch you guys later. Have a good one.